Determine the parametric equations of each of the circle. Okay, let us begin. So before beginning, let's quickly recap the parametric equations of a circle. So if we have a circle which is centered at the origin, its equation is given by x squared plus y squared equals to r squared. Then you can parameterize a point lying on the circle which is given by the coordinates x comma y. Then x will be given by r times cosine of theta. Here theta is the parameter, and y will be equals to r times sine theta. And if we have the circle which is centered at some coordinates h comma k, then its equation is given by x minus h whole squared plus y minus k whole squared equals to r squared. It also has a radius of r. Then we can parameterize a point lying on the circle with x equals to h plus r cosine theta, and y will be equals to k plus r sine theta. Fine. So here we have these two equations. We'll be using this to parameterize the given four equations. So let's begin with number 1. So here we have the first equation, 4x squared plus 4y squared equals to 25. Now this particular equation is not in its standard form because of the coefficient 4 which is in front of x squared and y squared. So we can get rid of it by dividing each terms by 4. So we get x squared plus y squared. This will be equals to 25 over 4. And further simplification is going to give us x squared plus y squared equals to, now 25 over 4 can be also expressed as 5 over 2 whole squared. Now if we compare it with the standard form, then our radius comes out to be equals to 5 over 2. So now that you have the radius, we can parameterize. So x will be equals to, we need r cosine theta. So that will be 5 over 2 times cosine theta. And then y will be equals to 5 over 2 times sine theta. So these are the two parametric equations of the first circle. Now let's go to the second circle. Now, the second circle is given in its general form. So what we'll do, we'll try to convert it to the standard form so that we can find out the coordinates of its center as well as the radius. Let's start with our given equation. We have x squared plus y squared minus 6x plus 4y minus 12 equals to 0. Okay, so first what we'll do, we'll combine all the terms containing x. So we have x squared minus 6x, and then we'll combine the terms containing y. We have y squared plus 4y, and then we will transpose this negative 12 to the right hand side to get positive 12. The reason why we combine the x terms together, because x squared minus 6x can be converted into a perfect square if we add 9 to it and then subtract 9 from it. So 9 is an extra term here. We have subtracted it, but instead of subtracting, we're adding it to the right hand side. Then y squared plus 4y, this can be also converted into a perfect square. So all you have to do is add 4 and subtract 4, or simply we can say we add 4 on the right hand side. Now x squared minus 6x plus 9, that this is nothing but x minus 3 whole squared, added to y squared plus 4y plus 4. So this is going to be y plus 2 whole squared equals to, so 12 plus 4, that's 16, 16 plus 9, that's 25, or simply put, it is 5 squared. So now we have converted the equation of the circle in its standard form, which means that h value that will be positive 3, k value that will be negative 2, and the radius is going to be equals to 5 units. So now we parameterize it. So parameterize a point on the circle. So x will be given by h plus r cosine theta, and y will be k, which is negative 2. So we have negative 2 plus 5 sine theta. So we have successfully parameterized the equation of the circle given by number 2. Now let's go to the third problem. So let's start with number 3. So here we have x squared plus y squared minus ax minus ay equals to 0. So we'll combine the terms containing x. So we have x squared minus ax, plus we'll combine the terms containing y. We have y squared minus ay. Our goal will be to convert x squared minus ax as well as y squared minus ay into a perfect square. So let's try to rewrite the expression. So x squared minus ax, now here the second term ax can be also expressed as 2 times the first term, which is square root of the first term, that's x, times Now we have a, but what we'll do, we'll write it as a over 2, so that after the 2 gets factored out, we are left with ax. Now this a over 2 tells us that we need to add a squared over 4 as the extra term and also subtract a squared over 4 from it. Similarly, we can do that to the second, the third and the fourth term. So here we have y squared minus, now ay will become 2 times y times a over 2. So a over 2 is going to tell us that we need to add a over 2 whole squared to it and subtract the extra term from it as well. This will be equals to 0. So now these three terms can be expressed as x minus a over 2 whole squared. Then these three terms will become y minus a over 2 whole squared. And we can transpose negative a squared over 4 and negative a squared over 4 to the right hand side to get a squared over 2. Fine. That means a squared over 2, or simply put, this is a over square root of 2 whole squared. So now we have the center, coordinate of the center, h comma k. So that's going to be a over 2 comma a over 2. And our radius is going to be a over square root of 2, which means that the parametric form will be x equals to the h value added to the radius a over square root of 2 times cosine theta. And the y value is going to be equals to a over 2 plus a over square root of 2 times sine theta. So we've successfully parametrized the circle given by x squared plus y squared minus ax minus ay. Now let's go to the fourth equation. We have x squared plus y squared minus ax minus by equals to 0. So we have x squared plus y squared minus ax minus by equals to 0. Okay, fine. So same as before, we'll take x squared and combine it with negative ax. Then we take y squared and combine with negative by. This will be equals to 0. Now we'll manipulate ax to get x squared minus 2 times x times a over 2. So this a over 2 tells us that we need to add the square of a over 2 to it and subtract it from the subtract a over 2 whole squared from it as well, which we'll do. We'll just keep a over 2 whole squared to the right hand side. Similarly, we can manipulate y squared minus by as y squared minus 2 times y times b over 2, plus we're going to add the extra term b over 2 whole squared and also subtract b over 2 whole squared from it. Fine. So this is now going to become x minus a over 2 whole squared added to y minus b over 2 whole squared equals to, now we have a squared plus b squared divided by 4. So that means our h value that corresponds to a over 2, k value will be equals to b over 2, and the radius that's going to be half of square root of a squared plus b squared. So now we're ready to parameterize. So x will be equals to the h value added to the radius, which is half times square root of a squared plus b squared times cosine theta. And then y will be equals to b over 2 plus half times square root of a squared plus b squared times sine theta. So we have successfully parameterized a point x comma y that lies on the circle, which is given by the equation x squared plus y squared minus ax minus by equals to 0.